All right, gentlemen, we're live.
All right, thank you very much for being here. This is our session on retrieval augmented generation. Caglar Demir is going to give the presentation. He studied in Istanbul, got his PhD from Paderborn University, and is now an expert in the area of machine learning on knowledge graphs and on information retrieval combined with knowledge graphs, retrieval augmented generation. Demir, the floor is yours.
Perfect. So greetings to all from Tintress. In this presentation, we will be focusing on, as Axel mentioned, on retrieval augmented generation or knowledge graphs, RDF knowledge graphs. Before diving into the details, I would like to briefly introduce myself. So my name is Caglar Demir, born and raised in Istanbul, Turkey. I have been living in Paderborn, a small town in North Rhine-Westphalia, since 2013. Previously, I did diploma in computer engineering, master's and PhD in computer science. And during this period of time, we mainly focus on designing scalable machine learning techniques, deep learning techniques, on knowledge graphs to tackle various problems. And since 2019, I'm a researcher. And in 2014, after spending quite a bit of time in designing techniques, as I mentioned, scalable machine learning, representation learning, deep learning techniques, or knowledge graphs, we realized that we have to channel this research to the industry. And we founded Tintress, and which will be clear soon. So overall, I would like to start as follows. In the last 2 decades, data has grown rapidly in many areas, as depicted here, including human HR, retail, IT, sales, research domain. Importantly, these massive data, is emerged often in a fragmented fashion. Namely, the data does not occur as in a one box. It evolves in a scattered, fragmented fashion. And although such fragmented data, fragmented big data carry important patterns in it, and we can leverage these patterns with machine learning techniques, handling such big data is a non-trivial task. So this data might not fit into your laptop, your maybe one node, and handling, cleaning, and detecting patterns on this data is a quite challenging task. And in these scattered data, it's incredibly important to basically connecting the dots between these points. In other words, establishing bridges between fragmented data lakes, as shown in the figure, is incredibly important to gain insights about the domain. And by gaining these insights, we can create business or scientific value. And in the last 6 years, at least, we have been researching, developing techniques to connect the dots. More specifically, we focus on one of the tasks we focus on is the link prediction. If you have multiple data points, how you can link these data points together to find the missing bridges. Our findings in the last few years have been published and well received in many avenues. Everything is publicly available, code, research papers. And we've mainly focused on RDF knowledge graphs because RDF knowledge graphs play an essential role in connecting the dots. As previous Shato mentioned, that the semantics allow us to make inference. Not only we predict and it's accurate, but we can ensure why we did this prediction. In Tintress, we productivize our technology in 3 categories. Our technology, Alexander Beagle, my co-founder, also will be mentioning, we first be focusing on handling this such big data. So you can have billions of triples, which a single triple might have string representation, maybe sequence of characters, text data in many languages, or you might have a very large theoretical information at T-box, so basically hierarchical knowledge about the world that the knowledge graph represents. And to handling this data, this large data, and in an efficient and a cheaper manner, we designed TentressDB. The details will be explained by Alexander Bigel. In this talk, I will be mostly focusing on these two modules, namely Tentress Ensemble LLM and multimodal RAG. So let's take a look at a RAG system in deployment. A user asks a question to the system. And let's assume that you have a bunch of databases connected to each other. And these databases depicted on the left-hand side can be relational databases, can be NoSQL-like databases, or can be rdf-triple store. And ideally, the user doesn't need to know these important languages to use these tools. For example, SQL language, Sparkle language. User asks some specific questions or maybe general questions. And in a RAG system, ideally, this question comes through the embeddings. A similar or important portion of this knowledge graph or DBs will be scanned through, found these important or relative or facts that pertains or relates to this user's question will be retrieved, depending on embeddings. And currently, there are plenty of embedding models, but they are default embedding models, so they might not be suitable for every applications. You might have some abbreviations company related. However, in the current overall systems, uses publicly available embedding models and retrieve these tasks, retrieve these documents to basically generate a response to user. And LLM, a large language model, publicly available or closed LLMs, takes this context, user's question, and generate a response. So that's why the RAG stands for Retrieval Augmented Generation. Although these techniques work quite well on many applications, however, creating a business value still remains a challenging task. And these challenging tasks can be categorized in three points. Can be summarized in three points. First, high cost associated with large language models. You would like to have your system to be deployed, and maybe 24 hours, the system should be available, and users can ask maybe hundreds, maybe millions of questions. And currently available LLMs, they have impressive reasoning capabilities, but they are costly. Importantly, data privacy. So this data, maybe you aren't allowed to share this data with other vendors, LLM vendors. In some domains, for example, pharmaceutical, a single data point cannot even leave your company, let alone the country. And last but not least, a domain expert, ideally you have a data scientist who has experience on retrieval augmented generation systems or information retrieval systems that can detect the suitable RAG indexing or RAG querying schemas. So you might have a bunch of databases and how to basically create a single document to be retrieved. And this basically introduces the challenges. And luckily, we have this graph RAG technologies and has been emerging, has been developed. So if I have to summarize, if I have to compare the vector RAG and graph RAG, and the first point comes into my mind as in a native RAG, you have a basic document level insights. Let's assume you have a text data, and your data science result assumes that each sentence should be a document to be retrieved. However, there are some questions that are more holistic view it's requiring to answer. So you can ask, what is the relationship between particular person and another person? And you might have another question that requires traversing your documents. And RDF knowledge graphs provides this holistic view. Namely, you can take a look at the entity and you can take a look at its first neighbors. And by looking at the first neighbors of this entity, let's assume a person, like as myself, you can get quite a bit of information about me. For example, Caglar Demir lives in this country, what is the profession, and etc. However, this information might be scattered around in your database. And it has been shown in multiple research papers, as well as very well-known SAP 500 companies, that performing RAG over knowledge graphs decreases the rate of hallucination, namely the factuality of the generated responses increased. Another point, in the native RAG, most of this, as I mentioned, that most of the techniques uses standard or open source embedding models, which are very well maybe tuned for a particular domain, but might not be suitable for your own company domain, basically company abbreviations. On the right-hand side the graph, we have graph embeddings that we can learn these knowledge graph embedding techniques on your data. And if you know that these features, these technologies exist, and adding this as an you don't have to replace maybe the default embedding setup, but you can add this extra bit of information to your ranking schema, and it improves the results in many domains, in many benchmark data sets. One more thing that I would like to maybe highlight, the deployment. So on the left-hand side, we mentioned that the basic document level insights. On the right-hand side, we say is the deep insights in contextual level. So how this happens. After you create on the right-hand side for the graph rec that I will be talking, after let's assume first top information about individuals extracted, it has been shown that you can apply some hierarchical structuring over this data. So you can combine these multiple, if you think about the graph as such a big web, and you can detect clusters on top of it. And detecting these clusters reduces the number of rows in your vector database. Therefore, you don't have to have millions of rows to be, or rows corresponds to embeddings, basically embedding vectors. You don't have to store them in memory, which basically leads you to deploy rack system in an inexpensive hardware scenario. Yet we can talk about hours and hours, and I would like to basically show you what we have implemented, and you can see our demo, and you can basically play with our demo during this presentation or thereafter. So you can basically enter this this demo. It's publicly available. You have to register it for free. And I would like to basically first start with the Tenders XAI part. Shuttle also mentioned this also in the very beginning of the presentation. The semantics is very important. And here I would like to show why this is important. There's an rdf knowledge graph publicly available, Arts Gallery, and it contains many information about the famous painters as well as their paintings. So you can write, I like Mona Lisa. I guess everyone knows how the Mona Lisa look like, this figure. And you can see that this is basically corresponds to the rack part. So or we retrieved, but we didn't generate anything yet. So giving this query, and these are top instances, top products, if you will, that are related to this topic. And you can basically add your feedback to the system. As previously, in our previous sessions, we also talked about that adding the human touch into the system indeed improves the results, either in the effectiveness, either the recall or accuracy increases, or you don't need to have millions of data points to get a suitable or satisfied accuracy. So here we would like to enter our feedback. For example, you can choose any of them you can play with the system, but let's take a look at the 10 on here, and let's take a look at the 9. What do you mean by let's take a look at? We ask this question, and these are the products, and we basically select retrieved documents that we are mostly interested in. And by doing this, what happens under is the following. Since we represent this data in the rdf knowledge graph, we tackle this retrieval augmented generation problem within all class expression learning that Axel previously mentioned. More specifically, we give this 10 and 9 basically correspond to the right this figure colored Mona Lisa in the Warhol, and 9 was, I guess, this Mona Lisa font. So basically, this is the title of the figure, and we say the system, the AI, basically RAG system, that hey, I was interested in initially Mona Lisa. After you show me some Mona Lisa or some documents retrieved from database, I am mostly interested on these two parts compared to the others. And during this basically few seconds, we observe an expression that describes what we are looking for indeed. So this means that these figures that we liked, and we give a feedback to the system, this corresponds to that we are mostly interested in pop art images along with the Mona Lisa. And this expression can be given to the LLM, large language model. Currently, we are using one of the open source models. And we can get an expression that you don't have to know description logics or first order logics to understand this, basically this simple expression. In some cases, it can be very large. Another important part, after we get expression, we can click this part. So basically, you can get the Sparkle query representing our intent to the system. And under the hood, we generate the Sparkle query, and we send back to this query to the very fast triple store. Obviously, it tenders here because of the fast response time as well as energy consumption. And it returns that although we are looking for a Mona Lisa, and we might be interested in other figures that belongs to this category. That's the one example. Now I would like to basically jump to the XAI part and why using RDF knowledge graph improves even if you don't want to have explainability. And for this, I will be uploading a n-triple format, a knowledge graph. This knowledge graph has been used in the data science group of Paderborn University, where we introduce our team. For example, Axel, Simone, myself, you can see, and many other researchers. And this data has been stored in RDF knowledge graph. And I would like to go to ChatGPT and upload the same data to ChatGPT. We can also go Anthropic or any other cloud, so this is very important. What I want to hear is the following. I would like to ask a very specific question. Who is the head of data science group? Obviously, I have many mistakes, science group. It's a very specific question. So you can answer, ideally, we would like to have a system that either answers this question in a very fast and very accurate manner, or we would like to have a system that does not answer this question, say, I do not know. It might take time here because of we aim to focus on decreasing the energy consumption. So we upload everything into the memory. If it's not used, we bring it down. Now you see that there's a very concise answer. And you can take a look at whether this answer is correct or false by taking a look at the particular triple that has been retrieved. You can ask exact same question to one of the most capable large language model. And you see the steps are going right now. So basically you are waiting. In some cases, we don't get answers. Some cases you can get an answer. So there is no basically reproducibility, also a matter of problem. And importantly, on the left-hand side, the number of tokens may be 10, 20. But on the right-hand side, number of tokens is basically increasing. So as a customer, you want to reduce the cost. On the right-hand side, unfortunately, you have to pay a lot of money. And although I don't want to say the money, but it's also the energy consumption, right? At the end, it might get a correct answer. Yet, it took more time, and this is state-of-the-art large language model publicly available. And it costs more money because of the number of tokens generated is more than left-hand side. And what is the main reason? The main reason is that, as maybe 20 years ago, there was a paper called Graphs, Not Strings. So on the right-hand side, you consider that, or system consider the input data as a string, as a sequence of characters, if you will. However, graphs are more than that. Graphs have a structure, and you can leverage. And here, I would like to depict this importance for the RAG part. I can talk hours and hours, but I don't want to. I have to abide by the rules. And that's all from my side. If you have any question, if something is unclear, please reach out. Thank you.
Thank you very much. So,
Pleasure.
So what do you think is kind of why GraphRag at all? I mean, you did answer that, but there's a little bit of GraphRag out there already. What would you think is kind of the
Absolutely. I mean, there are for
USP
example,
here?
the name. And Microsoft has a paper GraphRag. There are plenty of researchers going on, basically doing the RAG or RDF knowledge graph. And my humble opinion, the unique selling point of using graph is a structuredness. This structuredness allow, as a human being as well, we can reason better, basically multi-hop reason we can perform. For example, Demir lives in one country, and most likely that this person will be speaking that particular language. And you can get this pattern easier on a graph than text data. And at least this is the basically current research indicates.
So there's been a lot of papers and actually a lot of research suggesting that GraphRag actually helps with limiting hallucinations. Can you comment on that?
Of course. So and one of the reasons why this is the case, because of the graph representation leads to a better ranking. And if you rank, giving a user question, if you rank the possible potential answers better than the existing ones, then the LLMs basically have a better context to answer that particular question. That's one option of reduction of the hallucination. Important part, if we currently are working, and we will be get there in maybe a couple of months, that if you can convert a question to a Sparkle query, which is not feasible in text data, so you can basically allow a large language model to refrain from answering incorrect questions. For example, you have an RDF knowledge graph, you ask who is the owner of that particular company. And if you do not have the data for this, and if you have a correct Sparkle query, then the result will be empty. And we can tell the LLM, hey, we don't have any supporting document for that particular question. And therefore, LLM will have the ideally possibility to refrain from answering the question.
Core reject option built in. Thank you very much. We just had a 1 minute flag, so I want to thank you for your talk again. And this really ends this part of the meetup. Thanks again to the speaker, and yeah, see you in roughly 10 minutes.
Thank you.
Thanks.